So let's try with another example for both his methods and Robertson method. So let's say we have three, and let's say minus 3. Okay, so first of all we will transform the 3 to the binary system. Here we have 1 and the remainder is 1. Here we have 1, so I will write 1 and 1 here. So this is the 3 in the binary system, and I will transform the 3 to the 2 complements method. So here I will get 0. I will transform it with this way. Sorry. There are two ways to transform the from binary to the 2 complements form. First of all, which is the most famous way, is by adding the sign bits. Here, in my case, here I have 3 in positive, so I will add 2 zeros to make it in the 4 bits form. And the most significant bit is 0, so that's mean this number is positive. So here I have 1, 2, 4 and minus 8, so 1 multiplied with 1 will be 1, 2 multiplied with 1 will be 2, and here is I have 0, so the result is 3. And to make minus 0, I will write first the 3 and I will shift its numbers. Here I have 1, so it will be 0, 0, 1, 1, and this is the result that I got. And after that I will add 1 to the number. So here I have 0 plus 1 will be 1, and I will write the rest as it, because I don't have a number here. So this will be minus 3 in the 2 complements form. And the second way is, let's say we have 5. You put the number as it until you reach to the first one, and then you shift the rest of the numbers. And our result here I have 1, so I will put the first one and I will shift the other numbers. Here I have 1, so it will be 0, I will have 1. Here I have 1, it will be 0. Here I have 0, it will be 1. So this is minus 5. For example, let's say I have this big number. I would like to write in the 2 seconds form. So you put the numbers the same until you reach to the first one. You put it and you shift the rest of the numbers. Here I have 0, 0, and I reach to the first one, and I will write it and I will shift the other numbers. So here I'll have 1, 0, 0, 0. So this is the 2 complements form of this number. Let's say we have, for example, 0, 0, 1, 1, which is minus 4. I would like to shift it to its 2 complements form. So I will write the first numbers, 0, 0. I reach to the first one, so I will write it. And I will shift the rest of the numbers. Here I have 1, so I will shift it to 0. So here I have 4. Okay. This is another way for shifting to the two complements form, but I prefer the first way because I think it is clearer, and but the second way is a little bit faster. So let's complete first with the process method. As I said, we will write the numbers. We have -3 and 3. We will write it in the two complements form. First of all, I will see which number contains more zeros. Sorry, here the 3 is 1, 1, 0, 0. And -3 is, I put the first one and shift the other numbers. So the first one contains more zeros, so I will choose it to be the second number. I prefer this. Is not mandatory, but I prefer this way. So here I have 1, 1, 0, 1, which means 3. The second number is 0, 0, 1, 1. We put the second number here, 0, 0, 1, 1. And we put 0 here to see the case if we are going to apply a subtraction or addition or do nothing. Let's make a quick revision. If we get 1, 0 will be subtraction, 0, 1 will be addition, and 1, 1 or 0, 0 will result to do nothing. And so I wrote the first number here. I will write 4 zeros here because we have 4 bits, so I'll extend it to 8 bits and add this 0 to just know the case. So in our case here I have 1, 0 will be subtraction, so I'll subtract the first number. So I have 1, 1, 0, 1. I'll make subtraction. Here I have 1 minus 0 minus 1. I can't do it, so let's assume there is 1 here, so I will take 2 from it. So here I have 2. I will take 2 from it, so here I will write 2, and I will delete this 2 and put 1 instead. Here I have 2, so I will borrow 2 from here, so this will be 1. Here also I will borrow 2 from it, so this will be 1. So 2 minus 1 will result in 1. 1 minus 0 will result in 1. 1 minus 1 will be 0. And 1 minus 1 will be also 0. Okay, and here we have the same number because we don't have a number here. And we will do our first shift. We have 4, we start with 4 bits, so we'll do 4 shifts. The last number here is 0, so I will add 0 here. 0, 1, this 1 will be moved here. So here 1, 0, 0, 1. And here I will have 1, this one will be moved here. So in this case I have 1, 1, so I will do nothing. This is first shift, so I will do nothing. 0, 0, 0, 1, and here is our barrier. Here we have 1, 0, 0, 1. Here I have 1. So I will do the second shift. So here is do nothing. This is our first. This will be our second. Here I have 0, so I will add 0, 0, 0, 0, 0. This one will be moved here. So here 1, 1, 0. 0, and the 1 will be moved here. So here in this case we have 1 and 0, so this is addition. So I will add the first number, which is 1 1 1 1 1 0 1. 1 1 0 1 will be addition. 1 plus 0 will be 1 0 1 and 1. And in this case I will just repeat this number. Yeah, I have 1. And after that I will do a shift. Here I have 1, so I will add 1 here. 1 1 1 0. Here I will move this one here, so 1 1 1 0, and here the 0 will be here, so here I have 0. So this is our third shift. First of all, we make a subtraction, and we made a shift. Then we did nothing, and we shifted. Here I did the second shift, sorry, second shift. And here's the third shift. Now we will see the case. In our case here I have 0 0, so it will be doing nothing. So I will write the number as it 1 1 1 0 1 1 1 0, and I will make a shift here. Here I have 1, so I will shift it to 1. So I will add 1 here. 1 1 1 1. The 0 will be here. 0. Here I have 3 ones. 1 1 1. So this is our fourth and the last shift. So the result, this is the result. We will ignore this, and this is the result. So here I have minus 3 and 3 will result in minus 9. So let's see. Here I have here I have 1 2 4 8, but with 0, so we'll ignore it. Here I have minus 6. Here I have 16. So I will ignore these bits because they are repeated, and we have 9, so I can represent the minus 9 with just 5 bits. So I will ignore these bits. So here I have minus 16. So let's see. Here I have 7 plus minus 16 will result in minus 9. So our result is correct. Now I will move to Robertson's method. We'll move fast. So we will write minus 3 and 3 here. Minus 3, I'll write it in the 4 bits form. As we I forgot how, but let's practice again. So the 3 is 1 1. I will make it in the 4 bits form. Okay, then I will make the 2 complements form to obtain the minus 3. So I will shift the numbers. Here I have 0 0 1 1, and then I will add 1 here. So I will get 1 0 1 1. So this is minus 3 in the 2 complements form. So the 3 contains more 0, so I will write it here 0 0 1 1, and minus 3 is 1 1 0 1. Okay, as we did in the as I said in the Robert's method, Robertson's method. First of all, we ignore the last or the most significant bit of the second number, and we perform a normal multiplication. 1 0 1 1. We shift. We have 1 0 1 1, and we have 0 here, so we shift 0 0 0 0. We fill the gaps. Here I have 2 gaps, and here I have 1 1 1. Here also I have 1, so I will write 1 here, and we do the addition. 1 1 1 2. I will write 0 here, I will carry 1. Here I have 3, so I will write 1 here to carry 1. Here also I have 3, write 1 1. So the result I got 7 bits. So I got the result that I want, because here I have 3 bits. I multiplied it with 4. 3 plus 4, so I got 7 bits. So this is the result that I want. So now I started with 3. I will move to this last step. Here I start with 3 bits, so I will write 3 zeros here, and I will multiply the number that I ignored with the first number. So the number that I ignored, which is 0, so 0 multiplied with this number will result in zeros. 0 0 0 0. Now I will do a subtraction. So because I will subtract from 0, so the result will stay the same. So here I have 1 1 0 1 1 1. So this is the result. So the last method, which is true correction method, which was created by the author of the book. So I would really recommend you to check this method in the book, because I don't want the video to be too long. So thank you very much, and I'm sorry for my bad English and for the very long explanation. I hope this was helpful, and thank you very much for watching.